All right, question number one. Determine the intervals of the domain over which the function is continuous. And we talked a little bit about continuity with practice test number one, and we said that in order for a graph to be continuous, you have to be able to draw the graph without lifting up your pencil from the paper. If you have to lift up your pencil, your graph is not continuous. It has discontinuities somewhere. So let's see what's happening here with the graph we've been given. Well, we have a line, right? And we know that lines go on in both directions forever. And we're only concerned about the domain. They're not asking us about the range. So that eliminates some of our work for us, which is nice. So let's talk about the domain of basic lines. Lines that are in the form y equals mx plus b, which is what this is. Well, you'll recall that lines in the form y equals mx plus b, their domains are from negative infinity to positive infinity, right? And that would be the case here with our line, except notice that they've drawn our attention to this specific point, 1 comma negative 4, and they've drawn this point with an open circle. Open circles are special when graphing. What they're telling us is that this line, this graph, does not exist at this point, 1 comma negative 4. So since the graph does not exist at this point, that means if we were to draw this graph, right, we set our pencil down here at the top, we start graphing, graphing. Once we get to this point, 1 comma negative 4, we've got to pick our pencil up off the paper, skip over this point, and set it back down again to continue graphing. So the fact that we had to lift our pencil off the paper and put it back down again means there is a discontinuity in this graph right here at this point, 1 comma negative 4. So we can't say that the domain is from negative infinity to positive infinity. That's not true. It doesn't exist everywhere on this interval. It doesn't exist right here when the x value is positive 1. So let's go ahead, rewrite what our intervals are for the domain, taking into account this point that does not exist right here at 1 comma negative 4. So this is still a line, so it still exists from negative infinity, and as it's coming from the left to the right, from negative infinity, it's coming down, the x's are getting bigger, it hits positive 1, but it doesn't exist at positive 1, so we're going to say from negative infinity to positive 1, and we're going to use a set of parentheses here because we're saying do not include this value of 1. And then we're going to pick up again, so we use their union symbol. So we skip over, put our pencil back down, and then start graphing again. So we skip over 1, starting again, and then our graph goes out to positive infinity. And so there we have the interval of the domain over which this function is continuous. This is telling us that this graph exists everywhere on the domain from negative infinity to positive 1 but not including 1, and then pick up again at positive 1 but don't include 1, and then go out to positive infinity. So the only place this graph does not exist is at the point, or x value rather, positive 1.